Hello students, this is Dr. K. Rajashekar from La Excellence IAS. Today we are going to talk about ISRO's next venture, that is Suryayaan or Aditya L1 mission. After successfully launching Chandrayaan-3 with soft landing on the moon, ISRO now focusing on sun. Let us learn about what is this Aditya L1 mission. We have seen recently ISRO setting up the date for launch, that is 2nd September 2023 in the morning, just before noon. ISRO is planning to launch this mission. If you look into the details about this mission, you notice that this is going to be India's first space-based observatory to study sun. And it is going to spend roughly 400 crores in the same range as Chandrayaan-1, Chandrayaan-2. Of course, Chandrayaan-2 is more expensive, and Mangalyaan-1. So launch vehicle is going to be ISRO's workhorse called PSLV, and they are naming it C-57, Commercial Launch 57, and roughly it is going to carry 1500 kgs. Location, initially ISRO thought of placing this probe in low Earth orbit, but later it extended this to send it to what is called Lagrange point 1 or L1 point, a point that is present between Sun and Earth, but it happens to be 1.5 million kilometers away from Earth. If you know, Sun is 150 million kilometers from Earth. So 1% towards Sun, not too close, but definitely far from Earth's atmosphere. And it is going to take roughly 4 months, 120 days to reach there. And once placed, they are predicting about 5 years of life for this mission. So for 5 years, this mission is going to calculate, observe, provide information about sun. So why L1 point? What is this Lagrange points? Lagrange points are points of balance, you can say, between any objects with big mass. Like in this case, we are talking about sun and Earth. Between them, you notice that there are 5 points in the influence of this that you can see. And here Aditya L1 is going to be launched into Lagrange point 1 or L1 point, where we notice that gravitational force of Sun and gravitational force of Earth is at equilibrium. When you place a probe here which is rotating around L1, this is called halo orbit. A halo orbit, something that looks like a halo, something that looks more or less circular. This is where this probe is going to circulate and feel that balance. So without too much of fuel usage, this can survive here. So it doesn't consume too much of fuel, and on top of that, because it is there outside moon's orbit, it will not be disturbed by solar eclipses. So we will have continuous and uninterrupted view of sun, and at the same time, as I was mentioning, it will reduce the fuel cost. Is it the first time someone is placing something in L1? No, already there are few objects there, most important one being SOHO of NASA, which is Solar and Heliospheric Observatory Satellite. This is also present here. Next, what are the objectives, key objectives of Aditya L1 mission? There are different layers in sun. If you notice, sun has core, sun has what is called photosphere and what is called chromosphere. So there is photosphere and there is what is called chromosphere, and surrounding that, the immediate layer around sun is called corona. At core, we notice that hydrogen particles, isotopes are coming together, causing fusion, releasing huge amounts of heat. That is why the temperature at the core is roughly 15 million. It is 15 million degrees centigrade. Whereas in the photosphere and chromosphere, temperature actually drops. It reduces, it dips. But when it reaches corona, temperature comes back to roughly 1 million degrees centigrade, which has been a mystery. Scientists have some opinion related to this, but these kind of studies are important to shed light onto this phenomena and the details related to that. So it is going to study solar corona and its heating mechanism. What is causing heating of outer layer of sun more than middle layers? And also the reason behind origin and dynamics of what is called coronal mass ejections and also solar wind. We also hear about what is called solar flares. These are coming out of sun and coming towards earth, influencing earth. So they can study origin and dynamics of such process. Also, by placing these payloads at L1 point, they are going to study the impact around L1. So these are called in situ measurements on site. What is happening at L1 because of sun's activity can be studied here. And they are sending 7 payloads. Payloads are instruments, 7 payloads to carry out these studies. Out of them, 4 of these are meant for remote sensing. They are meant for remote sensing. 3 are meant for in situ studies. Remote sensing means an instrument that is sitting far away from the object collecting data. It has an advantage, as you see, because you are able to see things from far away and get a good glimpse about what's happening there. The most important one, as you see in the remote sensing part, are in total 7 payloads, is coronagraph, something that is meant for imaging corona. Similarly, they are using different instruments to pick up information in ultraviolet region, in low energy X-ray region, in high energy X-ray region. So they are measuring light coming from sun of different wavelengths, and it provides different information here. So UV imaging, X-ray imaging helps studying the layers of photosphere and chromosphere. They are going to observe the sun and these layers, photospheres and chromospheres. And the first one, coronagraph, is meant for studying corona. And then in situ measurements, effects near L1 region, like solar wind. You see these two, Aditya solar wind particle experiment or aspects, plasma analyzer package for Aditya, PAPA, Papa you can call. So these are meant for studying solar wind. Different layers, solar wind particles, and the last one, advanced triaxial high resolution digital magnetometer. Magnetometer, a meter, something that measures magnetic fields. Okay, it is going to study the effects of sun's magnetic field on other regions, like in this case L1. So these are the major payloads to satisfy the objectives that we were talking about. And these are set up, these payloads are set up on the Aditya at different spots, as you see. So what is the significance of such a mission? Why ISRO is performing something like this? Why L1 point? What are we going to achieve with that? So observations that are going to be made from outside the atmosphere, outside the Earth's atmosphere, because initially ISRO thought about placing it in LEO, but the problem here is Earth is acting like a filter. Lot of radiation that is coming towards Earth because of Earth magnetic nature and because of the filters that we have, like ozone layers, etc. We are filtering lot of radiation. So they are not reaching the radars or sensors that we have on the Earth. So we are going to solve that problem by viewing it from area outside Earth and going more towards sun, although not very close to sun, but more towards sun. Then understand how solar wind particles and as well as magnetic field of sun influencing Earth. We'll notice that last year, what happened, because when there is high amount of solar activity, the solar wind particles, coronal mass ejections coming at Earth can disturb power grids on Earth. They can disturb communication systems on Earth. They can disturb satellites on Earth. They can disturb Earth magnetic field. So these things can be addressed here. These things can be learnt here. Those impact can be learnt. It will enhance India's scientific capability. It will give unique spot for India, which we have already achieved and experiencing it after Chandrayaan-3 success. We will do that with Aditya L1-like mission. These are very complex missions. We require good amount of scientific advancement in that, and India is going to demonstrate through this mission. With that, we are going to get deeper insight into sun and hopefully prepare better, because if you provide a quick alert, early alert on these kind of events happening from sun, then we can take some measures to protect Earth from it. At least prepare to mitigate problems like that. We wish all good luck to ISRO towards this complex mission. Okay, thank you guys.